Okay, so let's solve Classwork 86, angles formed by chords, tangents, and secants. So according to problem 1, you have a diagram in which tangent ML and secant M and K are drawn to circle O. You have the ratios of arc measures Ln to measure of arc NK to measure of arc KL to be 3 to 4 to 5. Find the measure of angle LMK. So here we can designate the ratios in terms of x. For example, measure of arc Ln, we can write it in terms of 3x. Okay, so in this case, let's write 3x over here. Measure of arc NK is 4x, and we can write measure of arc KL as 5x. Okay, so now at this point we just need to figure out what is the x value. So how do you do that? Well, we know in a circle the sum of all the individual arcs is equal to 360. Okay, in a sense you can actually use the partition postulate at this point by stating that 5x plus 3x plus 4x is equal to 360 degrees. Okay, so if you add everything up, what do we get here? Well, that's 8, 9, 10, 11, and 12. X is equal to 360 degrees. Okay, so at this point, all we need to do is find the x value to figure out the, divide by 12 basically to figure out the x value. So in this case, x has to be equal to 30 degrees, okay? Okay, so now we want to find the measure of angle LMK, which is actually this one, okay, the one that I'm highlighting here. This is the angle that I'm trying to find. So we learned from the lesson that the measure, I'm going to write it out, measure of angle LMK is equal to the difference of the arcs that they intercept. So it's this arc, the measure of this arc, minus the measure of this arc over here. So I'm going to use a different color. There you go. So we want to subtract the measure of these two arcs, okay? Okay, so that is equal to measure of arc LK, OKL, going to keep the same convention as the problem, minus measure of arc Ln, okay, and then everything divided by 2. So I'm going to say times 1/2, okay? All right, so now we need to find the measure of arc LK, OKL. So the measure of arc KL is equal to 5 times x, or in this case 5 times 30, because the x value is 30. Okay, so if you do the math, you should get 150 degrees. Okay, and also the measure of arc Ln is equal to 3 times x, or 3 times 30, which is equal to 90 degrees. Okay, so all we need to do is substitute now and say, okay, measure of angle LMK is equal to 1/2 times measure of arc KL, which is 150 degrees, minus measure of arc Ln, which is 90 degrees. Okay, so that is equal to 1/2 times, and once 150 times minus 90 degrees, well, we know that is 60 degrees, okay? Okay, so the answer is what? Measure of angle LMK has to be equal to 30 degrees, okay? All right, so let me highlight that really quick. There you go. That is the answer, 30 degrees. Okay, let's go over to the next problem. Problem 2. In the accompanying diagram, measure of angle RST is 32 degrees. So we know that measure of arc QT, that should be an arc symbol over here, is 92, and measure of arc PR is 123 degrees. Calculate the measure of PQ. By PQ, what do we mean here? Arc PQ, okay? Okay, so here we don't have the measures of the arcs that they intersect. Basically, we don't have the measure of this arc and we don't have the measure of this arc, okay? As a matter of fact, we need to find the measure of arc PQ. So how do we do this? Okay, so what we can do here is designate one of the arcs to be equal to x. For example, I'm going to write here, let measure of arc RT equal to x. Okay, so I'm going to put that in the diagram, equal to x. So in this case, what is the measure of arc PQ equal to in terms of x then? Well, in this case, all we need to do is subtract 123, 92, and x from 360. So we do 360 degrees minus 123 degrees minus 92 degrees and then minus x, okay? So the measure of arc PQ is equal to 145 degrees minus x, okay? So let me just label that in the diagram, 145 minus x. Okay, so now we know that 32 degrees has to be equal to 1/2 the difference of their intercepted arcs, okay? So in this case, it's going to be 1/2 times 145 degrees minus x minus arc RT, which is x, okay? So let's simplify this. If we multiply both sides by 2, we end up with 64 degrees is equal to 145 degrees minus 2x, okay? So all we need to do is figure out the value of x, okay? So we can go back and calculate the measure of arc PQ. So how do we do that? Again, if we, let's say, subtract 145 from both sides, so we do 64 minus 145, you end up with negative 81 degrees is equal to negative 2x, okay? So from this, we can figure out what x is, okay? So what is x equal to? So we divide the whole thing by 2 and we end up with 40.5, okay? Okay, so that means that the measure of arc PQ has to be equal to 145 degrees minus the x. And in this case, x is just 40.5 degrees. So that means that we obtain a value of the measure of arc PQ to be equal to, so let's do 145 minus 40.5, 104.5 degrees, okay? So that is basically the answer. Now, what I highly recommend is to check if this answer makes sense. How would you check if the answer makes sense? Okay, so what I would do, I would just substitute the values, okay? And say, okay, we know that measure of arc PQ is 104. So we're going to write 104.5 degrees, okay? Minus the x value is 40.5. So measure of arc RT is 40.5. And we're going to divide this whole thing by 2, okay? Let me actually label it as the check here, okay? So because we're doing a check, and you're going to take the calculator and do 105.45 minus 40.5 divided by 2, and look at what we get, 32 degrees. It works, okay? So the answer is correct. Okay. Okay, so in problem number 3, here we want to, figure out arc BC for part A from all the given. So let's see. We're given what? 70, 50. How do we figure that one out? Well, if you look at chord CE and chord BD, they intersect at Q, correct? So let me write this down. Part A, they intersect at Q and create an angle of 40 degrees. So we learned in class that if two chords intersect, then the angles that they form is equal to the average of their intercepted arcs, okay? So basically 40 is equal to the average between 50 degrees and measure of arc BC. Okay, so let me write it out like this. Okay, so that means that we can figure out what arc BC is equal to, okay? So that's going to be 2 times 40 is 80, 80 minus 50, and you end up with 30 degrees, okay? There you go. Let me highlight the answer of 30 degrees. Okay, so now we want to find the measure of angle CPB. CPB, that one. Okay, that can be easily done, right? Because for part B, we know that the measure of angle CPB has to be equal to 1/2 the difference between the arcs that they intercept. In this case, it's going to be arc CD of 70 degrees and arc BC that we just calculated of 30 degrees. Okay, so here we end up with what? 70 minus 30 is 40, and times 1/2. We end up with 20 degrees, okay? So the answer for measure of angle CPB is 20 degrees. Very good. So for part C, it says find measure of arc AB. So how do we find that one? Okay, so does it say, let me see, tangent circle furthermore. Okay, so here we have 50. Okay, so can we figure out what measure of arc QPE is? They seem like they're bisecting, right? Okay, so they're bisecting. Therefore, CPB, we know that this is 20 degrees. So let me put that in the diagram. This has to be also 20 degrees, right? Let me put that into, let me write that in. That is 30 degrees. So what's the measure of arc AB? And how would you do this problem? Again, it's the same idea as we did before. So here we know that 20 degrees is equal to 1/2 of the intercepted arcs. So it's going to be 50 degrees, right? Arc DE and measure of arc AB. That is the intercepted arc. Okay, so that means that if we multiply both sides by 2, we end up with 40 degrees is equal to 50 degrees minus measure of arc AB. Okay, so that gives us a measure of arc AB to be equal to 10 degrees. Okay, and there's the answer. So let me highlight that and let me label that in the diagram. And then for part D, it says finish the problem, basically to find all the other measures if we can. We can find the measure of arc AE, okay? Basically, all we need to do here is subtract, we want to subtract all these numbers, 10, 30, 70, 50 from 360 degrees to obtain 200 degrees, okay? So we got that. Okay, so let me label that in the diagram, 200 degrees, okay? I think that should be it for problem number 3. Okay, problem number 4. Okay, this is a little bit more challenging now. Okay, so here we know that angle AOB, this angle over here, is 120 degrees. How would you prove that triangle ABP is equilateral? Okay, so how do we prove it? Okay, so we know that segment OA is the radius, correct? And segment AP is a tangent. So what do we know about the radius and tangent in a circle? That these are always perpendicular, okay? So therefore, they create 90-degree angles. Similar, this is also a radius, and this is 90 degrees, okay? So that means that if you look at triangles, so let me write this down. In triangle AOB, we have the following, that the measure of angle OAB is equal to the measure of angle OBA. Do you know why? Because triangle OAB is isosceles, okay? Because they have the two legs that are congruent because radii of the same circle are congruent. Okay, so we can figure this out, right? So this is equal to 180 degrees minus 120 degrees. So we subtract the vertex angle from 180 divided by 2. Okay, so that is going to give us a 30-degree angle. Okay, so that means that the measure of angle PAB, so it's this angle here in the diagram, this angle, and this angle, they're both the same angle, right? They both have the same measure. So that is equal to the measure of angle PBA, which is just equal to 90 degrees minus 30 degrees, which is equal to 60 degrees. Okay, that's great because we know this is now 60 and this is 60, okay? So how do we know that measure of angle P is also 60? Because the sum of all angles in a triangle add up to 180, so we do 180 minus 60 degrees, which is measure of angle PAB, minus another 60 degrees, which is angle PBA. So that is going to leave us with 60 degrees. Okay, so that here is 60 degrees. Therefore, by the definition, we can say that triangle ABP is an equilateral triangle. Okay? Okay, so let's go over the last problem now. Now that is a challenging one. Okay, so here we're not really given much. It says the acute, an acute isosceles triangle BAC is inscribed in a circle. Tangents to the circles are drawn at B and C. They meet at point D. So we know that measure of angle ABC is equal to measure of angle ACB. So these two are congruent, and they're both equal to 2 times the measure of angle CDB. So for example, if we let this angle here, actually let me use a normal pen here. Okay, so if we're going to let this measure angle to be equal to x, this means that measure of angle ABC is 2x. Okay, so this angle here is 2x, and this angle here is also 2x, correct? Okay. So what is the radian measure of BAC? So forget about radian measure. Let's find the degree measure. So that shouldn't be radian. That should be degree measure, okay? Because I haven't taught you radian measures yet. Okay. How do we find the measure of angle BAC? Basically, what is the measure of this angle? We're interested in this angle over here. So any thoughts, any ideas? So if you look at the angle ACB, that's 2x, and that is an inscribed angle, correct? So again, angle ACB is an inscribed angle. It's 2x. Therefore, measure of arc AB is what? 4x, okay? Because the inscribed angle is always half of the intercepted arc. We can say the same thing for arc AC, which is also 4x. Okay, and how do we figure out measure of arc BC in this case? And why am I asking what the measure of this arc is? Because my goal is, okay, if I can add up all the arcs in terms of x, I can actually figure out the value of x, because I know in a circle, if you add up all the arcs, all the measures add up to 360, okay? So okay, so here we know that, we have 2 tangents, and the angle created by a point that is created by 2 tangents outside a circle is equal to half the difference between the intercepted arcs, okay? So if you, for example, take measure of arc BAC, actually let me write in a different color. Okay, so measure of arc BAC minus the measure of arc BC, okay, So in that case, I mean BC, the minor arc BC, and you divide that by 2, that is equal to the measure of angle D, okay? So we know what measure of angle D is. That is x. So we write 1/2 is equal to 1/2 times. So measure of arc BAC is just 8x minus measure of arc BC, okay? So that means that 2x is equal to 8x minus measure of arc BC, okay? And if you do the math, the measure of arc BC is equal to 6x, okay? That makes sense, right? Okay, so now we know that the measure of this arc now is 6x. So what is x? Well, all we need to do now is add up 4x, and 6x, and set it equal to 360 degrees. Okay, so what do we get here? So that's 14x is equal to 360 degrees, which means that x is going to be 180 over 7. So I'd rather leave it as a fraction, okay? I mean, if you want to find the exact value, I mean the approximate value, that's going to be approximately equal to 25.7, okay? But I'm still going to use 180 over 7 and then round at the end. Okay, so how do we find measure of angle BAC? As you can see, the measure of angle BAC is an inscribed angle, and it's half of the arc that it intersects. So it's half of arc BC, okay? So that means that the measure of angle BAC is equal to 1/2 measure of arc BC, okay? And all we need to do is now substitute, because we know measure of arc BC, this part here, is just 6x, okay? So that means that that's going to be equal to 3x. So that means that the measure of angle BAC is equal to 3 times 180 over 7, okay? So that means that the measure of angle BAC is equal to, and here we can calculate, 540 over 7, which is approximately equal to 77.1 degrees, okay? And that's basically the answer. It's about 77.1 degrees, okay? All right, I hope this was helpful. Please let me know if you have any questions. You can email me. And other than that, I wish you a good day, and I'll talk to you another day. Bye.